Against the backdrop of increasingly fierce global technological competition, the semiconductor industry has already become the core strategic high ground that countries are vying for. In 2024, the U.S. semiconductor tariffs on China sharply increased from the original 10% to 34%. This move is undoubtedly a major blow to the semiconductor trade relations between China and the U.S. On the surface, this action by the U.S. seems to be an embodiment of trade protectionism, but in fact, there is a deeper intention of a technological war behind it. When facing the U.S. tariff provocation, China immediately took reciprocal countermeasures. This series of confrontations quickly pushed the competition between China and the U.S. in the semiconductor field to a fierce stage. This tariff war is by no means just a simple change in trade figures. It is related to a country's say in future technological wars. As the cornerstone of modern technology, semiconductor chips are widely used in various fields, from smartphones and computers to artificial intelligence and autonomous driving. Whoever can dominate the chip supply chain holds the key to opening the door to future technology. Judging from key data, China has always been highly dependent on semiconductor imports. In 2023, the value of China's chip imports reached as high as $410 billion. Every change in tariffs has a huge impact on China's import costs. Taking the US's increase of tariffs to 34% this time as an example, for every 1 percentage point increase in tariffs, the import cost will increase by $4.1 billion. Then, a 34% tariff means that China needs to spend an additional amount of over $136 billion every year. This huge cost will ultimately be passed on to consumers and enterprises through various links in the industrial chain. For enterprises, the increase in costs may compress profit margins and affect the development and innovation capabilities of enterprises. For consumers, they may face price increases of products, reducing their quality of life. This tariff measure by the U.S. is undoubtedly exerting pressure on China's semiconductor industry and even the entire economic system, trying to curb China's development in the semiconductor field. The significant increase in tariffs is like a huge stone thrown into a calm lake, triggering a series of chain reactions in the semiconductor supply chain and producing a remarkable butterfly effect. Taking the iPhone 16 as an example, the cost of the TSMC 3nm chip used in this mobile phone has increased due to the increase in tariffs. In order to maintain profits, Apple had to take measures to raise prices. In the US market, the price of the iPhone 16 increased by 15%, and in the Chinese market, it also increased by 10%. This not only greatly increases the cost for consumers to purchase the iPhone 16 but also affects the competitiveness of Apple products in the market. In contrast, the Chinese brand Xiaomi has shown a different coping strategy. By purchasing domestic NAND flash memory from Yangtze Memory Technologies Company, Limited, Xiaomi effectively controlled the cost increase rate and kept the cost increase within 8%. This case fully demonstrates the potential of domestic chips in cost reduction, as well as the cost advantages brought by enterprises choosing domestic chip suppliers when facing rising supply chain costs. In terms of enterprise coping strategies, in order to reduce excessive dependence on the Chinese and US markets, TSMC has transferred part of its advanced process production capacity to Japan and Europe. This measure is, on the one hand, to avoid the risks brought about by the China-US tariff war, and on the other hand, to explore new markets and seek a more stable development environment. SMIC, Semiconductor Manufacturing International Corporation, on the other hand, has chosen to accelerate the mass production of the N+2 process. By simulating advanced processes with mature equipment, it has continuously enhanced its own technical strength. SMIC's efforts have achieved remarkable results, and its global share of 28 nanometers production capacity has increased to 40%. This not only enhances SMIC's competitiveness in the global semiconductor market but also provides strong support for the development of China's semiconductor industry. At the consumer end, the performance in the electric vehicle field is particularly prominent. As a leading enterprise in China's electric vehicle industry, BYD has successfully reduced the cost of a single vehicle by 3,000 yuan by using domestic IGBT chips. This makes BYD more price competitive in the electric vehicle market and able to attract more consumers. However, due to its dependence on imported US chips, the starting price of the Model 3 of Tesla's Shanghai factory has increased to 280,000 yuan in the case of increased tariffs. This price increase has weakened Tesla's advantage in the competition with domestic electric vehicle brands such as BYD. The US's tariff suppression and technological blockade have forced China's semiconductor industry to accelerate the pace of domestic substitution, gradually changing from the initial forced response to an active strategic choice. The Chinese government has played an important role in promoting domestic substitution. The 14th five-year plan for the integrated circuit industry clearly promises to invest 1.5 trillion yuan in the development of the integrated circuit industry before 2025 and gives tax deduction policies to enterprises that purchase domestic chips, with the highest deduction ratio reaching 30%. Taking Huawei as an example, by purchasing domestic chips, Huawei can enjoy a tax deduction preferential treatment of up to 1.2 billion yuan. This policy not only reduces the cost for enterprises to purchase domestic chips but also encourages enterprises to increase the use of domestic chips, thus promoting the development of the domestic chip industry. In terms of technological breakthroughs, SMIC has made important progress. The application of the N+2 process has increased the yield rate of 28 nanometers chips to 85%, which is already close to the level of TSMC. SMIC's technological progress has won more competitiveness for domestic chips in the market and laid a foundation for the independent and controllable development of China's semiconductor industry. Huawei HiSilicon has also achieved a major technological breakthrough. The mass production of 7 nanometers chips has broken the US blockade on processes below 14 nanometers. The success of Huawei HiSilicon not only demonstrates the innovation ability of Chinese enterprises in the semiconductor field but also injects strong confidence into the development of China's semiconductor industry. Market data also fully reflects the accelerating trend of domestic substitution. In the first quarter of 2024, the revenue of Chinese domestic chip design enterprises increased by 45% year-on-year. Among them, enterprises such as Gigadevice Semiconductor Incorporated and Shanghai Welson Semiconductor Company, Limited, Welsemi, have successfully seized the market share of international manufacturers through domestic substitution. This growth trend shows that the recognition of domestic chips in the market is constantly increasing, and domestic substitution has become an inevitable trend in the development of China's semiconductor industry. Behind the China-US semiconductor tariff war, geopolitical factors play an important role, which has a profound impact on the global semiconductor supply chain, both positive and negative. When facing the tariff war and geopolitical risks, China is actively building a dual backup supply chain model of domestic plus Southeast Asia. SMIC has expanded its 20 nanometers production line in Malaysia, and Yangtze Memory Technologies Company, Limited has jointly established a factory with SK Hynix in Vietnam. This measure is, on the one hand, to reduce dependence on a single market and improve the security of the supply chain. On the other hand, it is also to expand overseas markets and strengthen cooperation with international enterprises. In this way, China's semiconductor industry can better cope with external risks and achieve sustainable development. However, the US is also facing its own difficulties. Due to the tariff war, the cost of Intel's Arizona wafer factory has soared, and the price of its 3 nanometers chips is 20% higher than that of TSMC. This price disadvantage has caused enterprises such as Qualcomm and Nvidia to turn to TSMC one after another to seek more cost-effective chip suppliers. The US tariff policy not only fails to achieve the goal of curbing the development of China's semiconductor industry but also causes damage to its own semiconductor enterprises and weakens the competitiveness of the US semiconductor industry globally. In terms of the reactions of third parties, Tokyo Electron of Japan announced that it would invest 30% of its R&D budget in Chinese joint ventures, which indicates that Japanese enterprises are optimistic about the development prospects of China's semiconductor market and are willing to strengthen cooperation with Chinese enterprises. ASML of the Netherlands has lobbied the EU to relax the export restrictions on lithography machines to China in order to balance the Chinese and US markets. This reflects that against the backdrop of the China-US tariff war, enterprises and organizations in other countries are also seeking to maximize their own interests and trying to find a balance between China and the US. If the China-US semiconductor tariff war continues, it will have a profound long-term impact on the global semiconductor industry. From a technical perspective, China may lag behind the US by 3 to 5 years in processes below 28 nanometers. Taking TSMC and SMIC as examples, the yield rate of TSMC's 3 nanometers process has reached 90%, while the yield rate of SMIC's 7 nanometers process is only 60%. If this gap cannot be narrowed in a timely manner, China will face greater challenges in the field of high-end chips, affecting China's development in cutting-edge technology fields such as artificial intelligence and 5G. In terms of the reconstruction of the global supply chain, Southeast Asia is gradually becoming the third pole. The chip packaging production capacity in Vietnam and Thailand is growing rapidly, but these countries generally lack advanced process technologies. For example, although Intel's factory in Malaysia has certain advantages in chip packaging, it still relies on the import of US equipment. This shows that Southeast Asia still has obvious shortcomings in the development of the semiconductor industry and needs to further strengthen technological research and development and industrial upgrading. However, in this long-term game, there is also the possibility of cooperation. Non-strategic fields such as automotive chips may become an exception list. Automobile companies such as Tesla and Volkswagen are actively lobbying the Chinese and US governments to exclude automotive MCU chips from tariffs. This is because automotive chips are crucial to the production and development of automobile companies, and the increase in tariffs will lead to an increase in the cost of automobiles and affect the competitiveness of automobile companies. If China and the US can reach cooperation in non-strategic fields such as automotive chips, it will not only reduce the costs of automobile companies but also help ease the trade tension between China and the US and create a more stable environment for the development of the global semiconductor industry. In the smoke of the China-US semiconductor tariff war, China is exchanging pain for strength. By accelerating the process of chip autonomy, it is continuously enhancing its own technical strength and industrial competitiveness in the semiconductor field. Although facing huge challenges and pressures, driven by policy support, technological innovation, and market demand, China's semiconductor industry is gradually realizing the transformation from relying on imports to domestic substitution. The US's technological hegemony strategy, on the other hand, is facing the dual pressures of costs and allies. The tariff war not only leads to an increase in the costs of US semiconductor enterprises and the loss of some market share but also causes dissatisfaction among allies. Some of the US's ally enterprises, for their own interests, have successively strengthened cooperation with China, which has weakened the influence of the US in the global semiconductor industry to a certain extent. In fact, there is no real winner in this tariff game. The confrontation between China and the US not only causes damage to the semiconductor industries of both sides but also brings a lot of uncertainties to the development of the global semiconductor industry. But it is certain that the global semiconductor industry will enter the post-globalization era, and supply chain security will replace cost efficiency as the primary consideration in enterprise decision-making. In the future, countries should strengthen cooperation and jointly promote the development of the semiconductor industry to achieve a win-win situation. Only in this way can we remain invincible in the global technological competition and make greater contributions to the progress and development of human society.